Welcome to this video about germ theory. So we're going to explore the origins of germ theory, which came about at the end of the 1800s, thanks to the work of lots of scientists, but in particular Louis Pasteur and Robert Koch. And these two scientists helped us to understand that diseases that are infectious are actually caused by microorganisms. So let's have a look at a definition of germ theory. Germ theory is, let's bring it up to the front, is when you have a disease which is caused by a microorganism because that microorganism lives in and reproduces in a host, so that might be an animal or a plant, and because it's living and reproducing, it is causing the disease. And if you transfer that microorganism to a new host, that new host will also get the disease. So if we think about germ theory, it came from somewhere. And what we're seeing in these images are what's called miasma. So this was an idea that disease came from bad air. And in this first picture here, you have the disease cholera being depicted in a cartoon in a newspaper. And you can see all the bad air depicted by this cloud, black cloud emanating from the top of this figure here, a sort of shrouded figure which is representing death. You can see the sort of skeletal remains of its feet and its hands sticking out and crushing all these people. And it says in the legend at the bottom that it's squishing the victors and the vanquished. So the idea that cholera will take anybody. But it's been caused by the bad air. And that was also being played out here. Now, you might be aware, you might have seen this in history lessons, and when the plague or the Black Death was around, people would put on these masks, and in the nose section of the mask, they would have sweet-smelling petals and perfumes in the hope that you would override the bad air, and therefore when you breathed in, you wouldn't get the disease. The word miasma or bad air still exists in some names that we have today for diseases. And if you think about the name malaria, that actually comes from the French, mal meaning bad, so bad air. And it was that idea that swampy grounds would cause malaria, which actually we don't know. We know it's not true because obviously it's a protozoan carried by a mosquito. So what else? If you don't believe it's bad air, you could believe in this. If you have mouldy grain in a container, it will produce mice. Everyone knows that. You have a container of mouldy grain. If you have some bad meat and you leave it around for a while, it makes maggots. And the mud of the River Nile produces crocodiles. There you go, there's the crocodile coming out of the mud. So of course they do. And this idea is called spontaneous generation. So that idea that life can come from nothing, from a vital force within the world. And we understand that that's not true. Cells are the basis of life, and cells have to come from existing cells by mitosis or meiosis. So these are the ideas that were pervading before germ theory came into being. And if we look here, we can see some of the major milestones in the development of the germ theory. Here we are way back at the beginning. It's not even on the timeline. We've got the miasma theory of bad air. But you can see that closely linked with the development of microscopes, we've got the idea that with a microscope we can see cells. So there's Robert Hooke. We've got Leeuwenhoek, the Dutch microscopist. He is able to see single cells. We've got the idea that if you are not clean, you will pass on disease. So we've got Semmelweis and Lister, making sure that if you wash your hands before you do surgery, then you will not get diseases in the patient afterwards. I've included this person over here. You might recognize her. She is Florence Nightingale. She actually comes in about here because she was famous for managing nurses in the Crimean War, which was a war between Russia, actually kind of in where Ukraine is now. So in Russia, between the Russians and the Turks and the British and the French. And she was incredibly fastidious about having her nurses wash their hands. And she was actually renowned for saving a lot of lives because of that. No infection was being passed on. And she had grown up with the idea of bad air, but was being turned over with this idea of washing your hands being really important, although she didn't really know why. And then we have some scientists starting to look at the causing of these diseases. So John Snow in London, looking at where cholera was coming from, which water pipes in the London water providing system were the ones that were resulting in cholera infections. You've got Pasteur doing his experiments to show that spontaneous generation is rubbish. There have to be bugs already there for more bugs to come. You've got Robert Koch, the German, doing his work to actually isolate the individual bacteria. So you can see in the mid to late 1800s, a lot of work being done. We know cells exist. What are they actually doing in there? So we now have this idea that there's things in the water or things in the air. It's not nothing that makes disease, it's something, it is life. And here's an amusing cartoon showing that as our understanding of technology gets better, there she is using a microscope, we can actually see in the Thames water. This is a bit of a tribute to the London Water Company. The water is disgusting. Who would drink it? So let's have a look at what work did Pasteur actually do. So he he demonstrated that you need to have life present for more life to grow. And what he did was to take a broth that was inside a flask with a special neck. Now this neck is open to the air here, but it's got a swan neck shape, so it's an S shape. And he heated the broth for quite a while, so 10 minutes to sterilize it. And then he showed that so long as the swan neck was intact, no growth occurred. The broth stayed clear and there was no development of bacteria or any decomposition. It didn't go off, it stayed perfectly clear and golden, and no growth happened. However, as soon as you broke off the neck and exposed the flask to bacteria from the air, if they entered the broth, then it would quickly go bad. So that was his experiment, showing that spontaneous generation does not happen. You have to have microbes there already for more microbes to grow. And what was Robert Koch doing? At a similar time, he was isolating bacteria from sick animals. He was working in particular on anthrax. Anthrax is a really nasty bacterial disease, particularly found in sheep and cows. Sorry, that's my really bad writing of anthrax there. He showed that, and he made up 4 postulates. Postulates is just a kind of posh word for rules or guidelines for how you can show that a disease is being caused by a microbe. If you take a healthy animal, you will never find the disease in their blood. So take their blood and try to grow disease from it, and you'll never find it because they're healthy. However, if you take the blood from a diseased animal, and you can see here, a diseased animal's blood has got bacteria in it, as well as the blood cells, and you can then grow the microorganisms separate from the animal on a dish. Now this is an agar plate. It's a special kind of agar called blood agar, so it's enriched with the kind of proteins you'd find in an animal. But you can see smeared all over it, bacteria have grown. Now, if we take those bacteria and put them into a new mouse that's healthy, you will make it sick. And you will be able to grow from its blood exactly the same bacteria that you were able to grow the first time. So here you have to be able to grow the bacteria separate from the host animal or host plant, and then show that those bacteria are also present in the next diseased animal. And that's what he said, that linking of what you can find in the first animal that's diseased to what's in the second animal that's diseased, and so on, that shows you have a microbe causing the disease. So these two big giants of microbiology, let's look at what they managed to achieve. So we have Koch over here. He is isolating the bacteria that causes anthrax. He then goes on to isolate the bacteria that causes tuberculosis and also the bacteria that causes cholera. And for all of these amazing isolations, he wins the Nobel Prize for Physiology and Medicine in 1905. And Pasteur really is a rock star of microbiology. He doesn't win a Nobel Prize, but he does show in 1863 how to pasteurize wine and keep it good for long periods of time. By heating up the wine to a certain temperature. We now mostly use it for foods and for milk, but it was used originally for wine. He also worked in the beer industry. Then he turned his attention to disease in silkworms because the French silkworm farming was being devastated by disease, and he did lots of work on epidemiology, watching the progression of the disease and isolating diseased individuals and keeping them separate so that the disease didn't get passed on. He then, when all these diseases started to be isolated by his German, I suppose he was a rival. There were lots of wars between France and Germany at the time, the Prussian Wars, but the two scientists were working in very similar fields. So he was, Pasteur started looking at cholera in chickens. It's a different kind of cholera to the cholera that affects us, but it has similar symptoms. And he actually he worked out how to get a vaccine for chicken cholera in 1879. He noticed that Koch had been purifying anthrax bacteria, so Pasteur was able to use that purified bacteria to develop a vaccine for anthrax in 1881, and he also went on to develop a rabies vaccine in 1882. So these two started off the microbiology kind of arms race, and this started by the end of the century. Many diseases had been characterized, and it really was the beginning of the end of bacterial diseases. But as we're going to see, it may actually be not quite so rosy anymore because of things like viruses that are coming to the fore, mutations, and also resistance. But this is our start into germ theory.